you so much.
Because that accelerator is 1,000 times more powerful than any ever built.
Are you nuts?
Shepard smashed a Higgs boson.
The scene was rife with scientific inaccuracy.
And then two beams are smashed head-on into one another inside of these enormous particle detectors. In those collisions, so much energy is fit into one place at one time that through E = mc squared, new forms of matter can be created that have much more mass than can be sustained in normal circumstances. So let's follow along for a second as the LHC accelerates a proton. In each of these successive rings, the proton gets accelerated to higher and higher velocities and contains more and more energy. In the first ring, it's traveling at about half the speed of light. But by the time it reaches the main ring, the 17-mile ring, the protons get moving at 99.999997% of the speed of light. Here we're going to follow one of the beams, proton beams, through this tunnel. If we can look inside of a proton, we'll find that this proton isn't a single particle at all, but is actually a collection of particles, quarks, being held together by gluons. Those quarks and gluons will be the things that actually do the colliding in a moment. Here we have one of the detectors at the LHC, and two beams of protons smashed on head-on in the heart of this detector, and you can see a spray of particles comes out. Hopefully, in a small number of these collisions, you could actually produce Higgs bosons in such a collision. We collide about 100 million pairs of protons together each second in this machine, and most of them do not produce Higgs bosons. In fact, Higgs bosons are extraordinarily rare in these collisions. About 1 in 10 billion collisions result in a Higgs. But in those few collisions that do produce Higgses, you can assign supercomputers to sift through this data and actually find evidence that this is going on. Making this even more difficult is the fact that the Higgs doesn't stick around for very long. It takes about 10 to the minus 22 seconds for an individual Higgs to decay into other forms of energy.
Shepard smashed a Higgs boson.
Making this even more difficult is the fact that the Higgs doesn't stick around for very long. It takes about 10 to the minus 22 seconds for an individual Higgs to decay into other forms of energy.
Shepard smashed a Higgs boson. Overloaded. Somehow you ended up here.
I can't take this, I'm out.